Hi, good evening. Good evening. I see we have Alina from Canada,
Hello. Hi.
and we have,
Can you hear me?
and we have Shao. Yeah, welcome. And how are you guys all doing? We have Aiko Fried from Amsterdam, Alina Zhang from Toronto, and Charles van Heerden here from Cape Town as well, I think. And everybody can hear me well?
Yes, I can hear you well.
Very good.
Excellent. I see Daniel also joined. Good evening, Daniel.
Hello.
Welcome.
Thank you.
Welcome to the club.
Yay.
I really want to welcome you all to this discussion. I want to keep it relaxed. It must be one of the better hours you spend in your month with a couple of interesting people, and I would like to know you all a bit better and your expertise. And as we go, when we start the discussion, really feel free to give all your opinions on the topic. Even if they are good opinions or bad opinions, you're welcome to give them. So I'll ask you to all mute your microphones now. You could all mute. Thank you very much, and then we'll start the presentation. So the first installment of our Machine Club, we talk about feature engineering, and I'm going to give you my perspective on feature engineering as seen from my profession. Currently working in a business that works a lot with SQL and Google BigQuery, the big data warehouse. Now, I made a problem statement here that is the topic of the evening and the focus for our discussion. Like, how do you build lots of cool features from a structured text statement that form useful inputs to your machine learning model? Now, I think it's very specific for somebody that hasn't built machine learning models before, so I'll break the statement down a little bit. Any type of model needs data, right? And this data is in the form of features. Now, these features are, you could see them as columns in the table, and these columns could be very useful for your model to learn from. So the idea is that you take data that you've got from somewhere, and you look at it and you inspect it and you analyze it and come to a conclusion that you need to aggregate it in a way that makes sense for your model. So this is the problem statement, but how do you do this quickly? And what frame of mind could you have to quickly produce hundreds, if not thousands of these features for your model? So onwards. The type of text we are analyzing, we are going to think about here is a SQL statement. A SQL statement usually comes in the form of you select some column from some table where something is greater or equal or less than something else. Obviously, this is a much simplified version of a SQL statement. You get very complicated ones when you start joining tables and information together. But this is the type of structured information we are talking about. Now, moving forward, my approach to build features from the statement, and I'll refer back to the statement now, are summarized in these 4 bullet points. So what do we know about the structure of this text? If I go back to the text, the structure is we have a column, we have a table, and we have some kind of equality statement. This is the general structure of a SQL statement. You don't even need the where. As long as you have the select, you could say select 1, and it will give the value 1. So what do we know about the structure? We know it has a place where the columns exist. We have a place where the table exists, and we have some equality statements. What do we know about the user behavior around this text? So that's the interesting part, is people behave with SQL. They perform the SQL at a particular point in time on a particular set of data, maybe at a certain time of the day. They do it very frequently, or maybe not very frequently. They have a particular behavior around SQL. I welcome Rita from, you're welcome, thank you for joining us. So we're talking about this SQL statement and what the features are that you could build from it. So you could see my questions are, what do we know about the structure? What do we know about the user behavior? And those 2 bullet points together can tell you a lot about what features you can build. So I can go and say, and I'll show you in my next slide, I've answered my own questions. I can go and say, once we know the structure, is there a way to create inputs that are switching on and off? So, you know, an input could be a real number, anything between, I don't know, minus infinity and plus infinity. Well, obviously, your computer won't be very happy with the infinity number. But and it could also be coded text, especially in neural nets. You have to have numerical inputs. So it could be a 0 or a 1. And in my opinion, I prefer 0 and 1s above real number inputs, because you could generate a wide. I see the text. The text to speech is is doing something strange. Sorry. Excellent. Now it's corrected itself. So apart from enjoying this presentation, you might enjoy the closed caption voice recognition below. In any case, we're talking about the type of input. So I prefer 0s and 1s. And you could generate a large number of 0s and 1 inputs, which I think is better for a neural network or a deep learning model. Because what are these models in essence? There are a bunch of nodes that switch on and off. You know, they switch on when some threshold function is reached, or breached, or surpassed, or whatever you would like to call it. When you trigger that function, it switches on, which then triggers the next function with some weights. So the idea is that, and I like this, generate a lot of 0 and 1 inputs. The last bullet point is, what do we know about this text's influence on any downstream process? So with SQL, the downstream process is the data, because you're querying a database. So what do we know? We know this text is going to get a particular data set for you, and it will have a particular size, and the data set itself will have some features itself. So you could say that you could try to get this information beforehand about what the downstream process would look like. I think between these 4 bullet points, you can generate a wide array of different features for your machine learning models. So let's go forward a little bit, and I don't have that many slides. I'm just going to cover these 4 bullet points in my answers. So what do we know about the structure of this text? That's the SQL statement, which I go back to here. What do we know about this? We know it has a defined grammar. This grammar is, decades old. The SQL grammar, there's different flavors of it. But what we can do is we can build counting features for words in this grammar. So if you have this entire grammar, you can say, how many columns did I include in my SQL statement? And that's your first feature. You count the columns. You can have many counters. You can build features for parts of the rule set for SQL that are present in the string or not present in the string. So if you have the entire rule set, like does this SQL query have a table? Not all SQL queries are querying tables. So you can say true or 1. Yes, it has a table. Does it have columns that you're querying? Yes or no. Does it have a where clause? Yes or no. And the other clauses that you get, like the having clause, the with clause. Does it have an equality, and how many equality strings or statements does it have? And so you can go and build counters of the structure of the SQL statement. Right. So let's take a breather and think about the next sentence. You can add vocabulary lists, 1 feature per word. Now, Google BigQuery has a list of what they call reserved keywords, and those are keywords that you may not use as column names or variables in your statements. They are meant to be grammar. So you can get complete lists of these grammars or these vocabularies, and for each of those words, you can go and count how many of them exist in your SQL statement. Then you have a whole bunch of features. Let's say if you have 100 words in the vocabulary, you already have 100 features, and for each you just have to go and count how many of these words exist in your SQL. Right. What do we know about the user behavior around this SQL? I like all of these question statements: when, why, how long, what style, how often, how early, at what point in the day, and at what date since the first interaction with the text. So if I am an engineer or an analyst running a SQL statement, I can say, when did I run this statement? Did I run it on a Tuesday? Did I run it at midnight? Why did I run it? That's maybe a more difficult one to answer. But maybe there's some context there. Maybe you ran it to do analysis. Maybe it's a routine machine job that runs once every 5 minutes. That might be some information you have. And it could be useful to build features around the SQL. How did you run it? Did you run it automatically again? Or did you run it by clicking in some interface? What software did you use to run it? Did you run it? And then maybe part of the how is how often, which is also in this list. Did you run it every 2 seconds? Did you run it, what's the frequency of your querying around this statement? What is the style of your SQL? Are you one of those people that use only lowercase wording or variable names? Do you never use carriage return? Have you got comments in your SQL? Those are interesting features to build, and we probably in this discussion already had a couple of 100 features already about this statement. How early? What point in the day? This is one I like a lot because data in databases grow over time. If you query, and most data is like this, I believe, especially in the app world and the software as a service world, where you get data from customers hourly. When you query in the morning and when you query in the afternoon, the data that you get back is different. It's bigger in the afternoon. So maybe it's a good way to predict the growth of data that you are querying based on the SQL statement and when it was run in the day. And the last one here, at what date since the first interaction with the text? So you could say how many minutes passed since the first time I ran this. So you could have kind of a longevity and kind of a time frame tied to this SQL statement. Let's go to the last main slide here before we open the discussion. Once we know the structure, is there a way to create inputs that switch on and off? So how do we do this? Like create zeros and ones from things like counters and things like names. How do you, for instance, take the name of a person and encode it as a feature of the SQL? If I want to know the name of the analyst, what can you do? So computer science has a bunch of cool tricks, and there's one trick called hashing, and hashing is used widely in encryption and in all facets of production systems. They provide a way to generate unique numbers. So once you have a unique number, you can generate unique input triggers for a neural net. Some hashes are very big, like if you have a hash function that generates, and this is the property of a hash function, most of them generate fixed length numbers or number of bits. So let's say I take a very small one that generates maybe 64 bits. The chances of that hash being the same it's quite a high likelihood if you have a very small hash. But sometimes it's useful, right? You can generate 64 input bits from taking, for instance, my name, Eben, encoding it with a hash into 64 bits, and then taking each of those bits as an input to the neural network. I'll have a link later on to show how somebody takes the not just the bits, but actually the total number representation of that. So for instance, 2 to the power of, I don't know, 28, and generates that amount of inputs for the model. But that's not sustainable. I mean, some architectures cannot even handle that large number of inputs. But in any case, I have an interesting link about that for you in my last slide. The last point here, how I think about feature engineering, is what do we know about this text influence on any downstream process? Like I said before, how much data did it scan when the last time you ran it? That's historical data that you might have. And this interesting one, how long did it process? It tells you a bit about the underlying architecture of the system that's going to process your SQL statement. Right. That being said, here's some resources, keeping it nice and short and compact for you. This hashing trick I'm talking about in ML, there's a link for that. I'll share the slides with you offline or in the comments. And then there's also a book suggestion about feature engineering and a GitHub repo for the a whole bunch of Jupyter notebooks from this book, which is really useful. Right, so what about next time when we have this machine club? We're going to recap some questions and comments from this episode, probably some comments that we might get in the future from YouTube or through email or Twitter or anywhere else. But here's some topics that you guys alluded to, you're interested in, things like state machines, blockchain and ML, predicting the rise and fall of cryptocurrencies, speech recognition. We have some speech recognition experts in our group doing some magic with statistics. I'm talking about you, Aiko. ML and the resilience of complex systems, the prediction of network growth, and maybe you could have a prediction on what the next topic should be for Machine Club. Now, I'm opening the floor with these questions for you. You're welcome to unmute your microphones and we can have a chat about this. Have you personally had to feature engineer input data before? And was it text-based like mine? How did you approach it? I'm very curious to know. And then we can step through some of the other questions. Maybe let's take the first one. If any of you want to have a quick rundown of how you approach feature engineering, then you're welcome to say. Nobody keen to have a chat?
Well, it's helpful. Thanks.
Cool, Alina. Alina, did you in your career so far, were you faced with some feature engineering tasks?
Yeah, for sure. But the idea you shared today, especially about the hashing part, is inspiring. Yeah.
So you think the hashing is interesting?
Exactly.
Yeah, I think hashing is typically a non-linear function. So you want to just be careful when using hashing. I think it is useful, and I've used it now myself before to generate inputs like this. I, for instance, generated 256 inputs using the SHA-256 encryption hash on a piece of text. And it's very useful, especially when if you want to generate keys for your, unique keys for your statements. So instead of working with this entire text, it has two functions. You can generate 256-bit string and use that only, and to compare it with other strings, or you can just generate 256 inputs. Just be cognizant that it is non-linear, and see how your model performs when you start using it. It definitely helped me recognize different SQL statements. Any other thoughts on feature engineering using textual data?
Eben, it's Jonathan here. Can you hear me?
Yes, Jonathan, hi.
Hi, thanks. Apologies, I joined a little bit late, so I think I missed the introduction, but is the feature engineering, are you trying to specifically try to interpret SQL statements and make context out of that? Is that what the overall objective is?
Yeah, so this example, I'm giving you one use case that is specific to my job. So I work at SuperQuery, and we take billions of SQL statements, and we try to predict certain things from them. So one of the things we try to predict is what will be the cost of running this SQL statement on the database. And to be able to do that, you can, in my opinion, and this is part of my general set of thinking points about this, is usually you can look at the actual statement and the architecture or the structure of it, or you can look at the data that it is going to scan or obtain for you, or you can look at the user behavior thereof. But this approach is not specific to SQL. I think you have lots of places in the world where people interact with text, websites, shopping websites like Amazon.com or Takealot.com in South Africa. There's a whole bunch of them, and people interact with text all the time. And you could take those statements, consistently, and use the same kind of techniques on them. What do people really want? How are they behaving? Are they, asking a lot of times in a row? And what is the structure of their text? I think SQL is a little bit easier because it has a very defined grammar, and vocabulary, and structure, syntax. Whereas human speech, I don't know, maybe somebody like Daniel can give his thoughts on this. I think it's also structured, but a bit less, I guess, than a language like SQL.
Yeah, if I can comment, one of the things that I think is interesting, if you're coming from a natural language point of view, that's basically a similarity in SQL, I think, is you can distinguish between grammatical words or tokens and function and or grammatical and content words. So your content words would be things that identify tables and columns, and those basically are open class. Like you have an possibly infinite amount of variation that you can expect there. Whereas in your grammatical words, you obviously, that's part of the structure of your sentence in the SQL sense. So it seems to me that one of the first things you might want to do is to kind of identify your vocabulary of your open class words, so that would be your tables and your columns. That can vary or may vary in a specific context. So let's say the context is a specific user or a specific organization. And what you might want to start figuring out in the background is how large is a specific table and a specific column. So I would say, like I said, an interesting thing here is you could try and focus on the open class entities first. And once you've kind of identified those and have some way of trying to represent those, maybe because you want to capture the size of what's behind them, you could probably move on towards the relationships given to you by the grammatical words, like your while statement and things like that.
It's very interesting. And do you believe that SQL is, in a sense, easier to work with than natural language?
Yeah, probably. I mean, if you know the specific natural language, then you can obviously, in a similar way, make a list of grammatical words and kind of so you'll have a list almost like you'll have in SQL. If you don't know the language, you can also infer those words by just looking at the ones that occur more frequently. So typically, the more frequently occurring words, high frequency words, are grammatical. So, but yeah, I think you're right. In the case of SQL, it might be a little bit easier because you already know what that set of words are, and you can focus on other things first, I would presume.
It sounds excellent. Now, SQL is this unique language, really, that interacts with data. Not that many languages interact with data like this. Even though it's I wouldn't say out of another era, but it's still probably the most popular language used by far to interact with data anywhere in the world. So thank you, Daniel. Moving to the next question about these ways of generating feature data. Do you know of any pitfalls to avoid when you approach these things in this way? I know generating lots of features has got the implicit problem that you have to probably reduce them again at some point because some of them might not be very useful. If any one of you have some thoughts along this line, you're welcome to say.
I don't have anything smart to contribute even, but I would like to know how you would prune features. Maybe a secondary question to this question.
Yeah.
So if you have a couple thousand columns and in your case, how would you find out that these columns are similar in information content, and how would you decide what to drop or how to combine them?
Yeah,
but, maybe
that's an excellent question. I think there's a whole branch of machine learning devoted to feature selection. So this presentation about feature engineering and as this very close brother called, or sister called feature selection, which is exactly what you're saying. You're pruning features that are of less importance to the output of your model. Now, this is my opinion. I haven't worked with all algorithms out there in ML, but I think it's a little bit harder with deep learning models to know which features are good and which features are not that good when you run the model. I think there's with other base ML models like support vector machines, tree-based methods. I think there are some better ways, easier ways to see which features are problematic. There's one thing I should actually put the link also in this slide. There's a thing called ELI5, which is they call it permutation importance. It's an algorithm that some guys put together that looks at probably the weights of the deep learning model as your model is being trained. This ELI5 algorithm analyzes the permutations and sees which one of these have an influence on changing your weights, and then it gets ranked. So you can get an idea of which ones are the most important. But it's a little bit tricky in this sense that one feature by itself might not look important, but when you use it in conjunction with another, it becomes very important. And this is where the caveat lies. I think it's a little bit tricky. But this,
Great. Thanks for that.
no problem. I think Eli5 is a good start. And then there's some general techniques. I think it's a very good idea to look at the correlation of pairs of your features. So take pairs of all of them, see which ones are very highly correlated, and try to remove correlated features. And I also think it would. I also think this would work a little bit less well if you really want that information to be there. Like if you hash something, you really want all the bits of the hash to be there. You don't want to remove some of them. Then you're changing the whole underlying structure. So some things to keep in mind. Great, that was a great question. And do you guys do this now? I know I do this professionally, and I know that somebody like Eiko might do it in a research environment. I'm not sure if anyone else has like done this textual, and maybe Daniel as well, in a research environment. You know, what does a real-time engineering flow look like? I don't know if Charles is still here. Maybe he has got some thoughts on real-time feature engineering flows. And if he doesn't, I have some thoughts as well.
Yeah, but as I say, you're telling me more about a world that I don't know too much of. It's a very interesting talk.
Interesting.
So something that I plan to look at within the next week or two, and it'll be interesting to hear if you've worked with this before, are word-to-vec models, which is just another way of encoding text. I'd be interested to hear if you've worked with it before, how you think that compares with using something like hashing, because this, of course, gives you context, and it also enables you to learn which concepts are similar and then extract information that way.
Yeah, I've definitely not worked with word2vec before, but I have heard of word2vec. I think it's very popular, and I think it's a very good algorithm from what I know about it, or what I've heard about it. Maybe Daniel has used word2vec in his research. Daniel, do you have experience with word2vec?
No, not really. Only what I've also read about it. I think, like Charles said, I think it's an interesting way to vectorize words and then create vectorized representations of pieces of text. But I don't have any practical experience.
Excellent. Okay, no, that's fine. I think it's a very good topic, Charles, and I think we should, like you're saying, you're also going to look into it. I think it would be an interesting topic for a discussion. I see you pasted the link for us. I think it's definitely worth a look at. Very useful. Great. Let's move forward to the next. Let's see if I have many more slides. I don't have. In my slides, you will see the resources, and I will share that with you. Now we have another 30 minutes, and I think this part is the interesting part. I would like to know, and I'll switch off the presentation, a little bit about your your current job or your current work or interest in this field. Just a minute or two. If each of you could tell us what you do, I'll go first. So I am, as I said, working for a business that analyzes billions of SQL statements, and I'm trying to build models, learning things like what is the cost of these statements predictively, how long will it be processed by the underlying architecture, so you can add value to customers. You know, you can take a business and tell that business, somebody in your business, like all your analysts together, are doing X amount of SQL statements. This is going to be the total cost for them at the end of the month. These are the types of statements they are doing, and one guy is doing $1,000 queries every second day. So it really would help businesses to focus their analytics behavior and try and add value for customers. This is my current profession. Maybe we can start from maybe Alina. Alina is a colleague of mine. Maybe she can tell you what she's working on. Alina, are you still with us?
I'm mute. Okay. I'm working on a previous. I'm working as like a data scientist for a startup, and I built some prediction model to do some prediction for the real estate market, and also have some behavior analysis of the owner of the properties. And currently, I joined SuperQuery, and we will work on the models for like the cost model, and the like the prediction of the cost of the queries, things like this.
Very cool. Yeah, Alina has a lot of experience, as you said, in property price prediction. I think that's a classic ML problem. I think it became famous with this Boston house price data set that's out there.
Yeah, there are some public data sets, and we also got like from 2 data sets company. So for each of them, we fetch like millions of records per month.
Wow, millions of records.
There are information about the property itself, and also about the owner, like the family shape, the loan, the mortgage, the salary, things like this.
Fascinating. That's very useful information. Yeah, data scientists definitely love big numbers.
Right, and it's very expensive. We bought the data sets.
Oh yeah, that's big. It's yeah, very expensive data set, as you say. Cool. Yeah, excellent. Charles, what are you currently working on?
Too many things. I'd like to focus a bit more on what I'll tell you about last. So a colleague of mine, Etienne Barnard, and I started a business about a year ago. And our primary focus is on speech analytics for call centers. But a year ago, we weren't sure what we're going to do, so we also branded ourselves as data scientists.
Okay.
So right now, we're collaborating closely with a call center in Cape Town, and we're doing general data science for them, and then also building a South African English speech analytics system. And we also plan to extend that to a couple of other South African languages. As far as data science goes, I'll maybe just highlight the current problem that I'm working on, which is also quite interesting from an ML perspective, and that is to come up with something that predicts whether semi-skilled workers with little or no experience will do well in a specific call center environment. In this particular case, debt collection. It's an industry with a very high churn rate, and it's expensive to hire the wrong people, because it typically takes you a couple of months to realize that, and then to find new people costs a lot of money. There's a couple of products in the market that try to do this, but we haven't come across any that are very successful in the South African market. And then, yeah, with speech recognition, basically trying to get insights into the hundreds of thousands of calls that call centers save every single day that are just lying there. And all that information is dormant right now, and we hope to unlock that soon.
Do you believe that you'd be able to predict the credit worthiness of an individual based on the way that they talk to the call center operator?
We hope to learn things like that eventually. Right now, we're really looking at very basic things, looking at people's credit history, personality tests. We want to cast as wide a net as possible and see if we can find correlates with how well specifically agents do within a call center. I know there are credit bureaus in South Africa who have done some work on predicting if somebody is creditworthy. And I think the most, it's very interesting, the most predictive feature that they found was how often someone speaks to their mother. And if you talk to your mother a lot, then apparently you get an indication that you're creditworthy.
Very creditworthy. Excellent. Yeah. So if I know this, I'm going to start speaking with my mother soon a lot. And hopefully I'll get a line of credit. No, thank you very much for that, Joel. That's fantastically interesting work. Daniel, what are you currently, the highlights of your current position?
So currently I'm working for an e-commerce site, and the main thing we've been working on for the last, I would say, a year or so is the search functionality. So basically, it's a classic searching for products and then relevance ranking of things. And I think the main challenge there is just to use so firstly, I think there are two parts of the issue that you could kind of approach these things. Firstly, you want to understand what is the user's intention with a search query. And I think that ranges from, for instance, in the case of e-commerce, someone who just wants to browse around on the site looking for nothing specific, but just to see what's on there. And the other side of the spectrum is you've got users who are looking for very particular products.
Like Christmas gifts and
yeah,
things.
like Christmas gifts and things like that. So you have to firstly come from that side of things and try and understand from very short text queries. You want to kind of gauge the user's intent, and then given that you know something about that, you need to kind of blend the other signals that you have to both retrieve and relevance rank the result. If it's a user that wants to just browse a site, you might just focus more on either user interaction data that you may have collected, or just like fall back on more like product specific data that you have. So you've got products data about products, you've got some history that you've got, and you've got user interaction, and all of these things are useful signals to use to do relevance ranking. But I think there's no fixed solution, so that's the interesting problem.
And do you have your own in-house relevance ranking algorithms, or is it off-the-shelf predictive models?
It's at this point it's not very sophisticated, but it does incorporate quite a lot of different signals. So I think it's probably going to increase in sophistication in terms of how we're actually mixing these signals. But in terms of the number of signals that we use, yes, it's already quite complex.
It sounds like interesting work. I'd love to hear a bit more about that. It's like understanding the inner workings of like an Amazon website, a shopping e-commerce website better. That's an interesting topic.
Yeah.
Cool. Jonathan, are you still listening with us?
Yes, thanks, Evan. So I'm currently working in pharmaceutical industry.
Okay.
Previously, I was working in the mining and metals, but I've sort of done my PhD and kind of finished that, and now I've moved into the pharma.
The bigger thing.
I guess. So I'm working on a very broad range of modeling. So I'm not really into data science or machine learning or specific tools like that. It's a very broad modeling.
Okay.
And the kind of vision that I've put together for the drug development is we want to basically optimize the amount of active ingredient. So that's the very expensive material that basically addresses the problem with the patient.
Yeah.
And we want to basically minimize the amount of API or active ingredient that's used in the development process.
You have an optimization problem.
It's a type of optimization problem. It's really understanding what are the different processing technologies, whether it's in chemical synthesis or in the formulation development. So basically mixing the active ingredient with excipients, making tablets or
Wow.
and then the other area is on the actual patient side of it. So it's to understand, to model how does the drug get dissolved and absorbed into the body, and what is the mechanism of action that takes place. So it's quite a
called pharmacokinetics, or what is it called?
Yeah, so there's the PBPK, so it's physiologically based pharmacokinetics, and there's also the pharmacodynamics, but that's more sort of a clinical development. So it's really around the broader value chain, and the vision is really to, if you take whatever 50 or 100 billion euros to develop a new product, and you take, say, 10 to 12 years, we want to compress that into what I predict is a 70% reduction.
Wow.
In this, if we are able to use modeling tools to predict this.
Incredible.
So we can
add a lot of value for you.
We can really optimize on drug development. Yeah.
Wow, incredible.
Anyway, that's the vision.
Yeah, thanks for that. I think there's a couple of good modelers in this group. Maybe you and Aiko should have a chat. I think he's an excellent modeler.
No, that'll be very nice to have a community on this.
Wonderful. Great. Rita, you have an interesting story. Could you tell us where you came from and where you're currently working?
Sure. Hi, everyone. So, like Evan says, interesting is a nice way of describing it. So I'm actually at the moment a full-time student. I first worked as a journalist, then was in the nonprofit space, and between all of that sort of did a PhD in heritage, basically pretty much just because I was interested. And then sort of towards the end of last year, I started worrying about where I might find a job afterwards. And I think I was searching on WITS's website because my library books are always late. And then this message popped up to say, hey, there's this new e-science course with a pretty cool bursary. And I was like, well, I don't know what to do next year. So let me see if I get in. So that's what I've been doing the last year. It's sort of, it's a new degree at WITS, which is actually pretty cool in the sense that they bring MSc and MA students together. So people with sort of a more traditional sort of STEM background, and then a bunch of us from humanities together. So it's been pretty cool to sort of see the different perspectives. And what I'm doing at the moment, which is really no kind of fancy machine learning at all, is everyone that comes from South Africa will know, obviously, that land reform is a very big topic at the moment. Yeah. So I'm doing for my research report next year, I'm sort of doing text mining on a bunch of documents to kind of get a sense of how views have changed over time. So I'm taking this court case from 7 years ago about a struggle song, but actually land reform was quite a big part of it. And I'm looking at that, and then some of the submissions toward the recent parliamentary committee, and doing some text mining and some other documents as well. So that's kind of what I'm doing at the moment.
Are you extracting sentiment from these documents? I mean, I can imagine taking a lot of songs that were sung during times like those or these, and then processing all of these songs to get the sentiment and the real feeling of people behind that.
I did like sort of a smaller project on one set of the documents that I'm going to do next year, and I did some sentiment analysis, and it was quite interesting to look at that. Like, some of it was also a bit strange that you have to like sort of, I needed to exclude some things, and it seemed like what's quite interesting, obviously, that with sentiment analysis, it doesn't see the context. So if you're being sarcastic and those kind of things, it doesn't see that. And that, obviously, the documents I looked at was a court case. So there was a lot of that. And I think it would be quite cool, actually, to get something that's more for the South African context, because like you've mentioned, if you could do that on different songs, how do you do that with different languages and those kind
of sarcasm is almost like a Turing test for a machine.
Yeah.
If you cannot get your sarcasm, then the machine talking. Oh, thank you, Rita. That's incredible. Do you have one more thought there? What do you plan for next year?
You can't ask me that.
Okay, I won't.
The answer is 42.
Okay, excellent. It's a good answer. Cool. Thank you. Aiko, you still with us?
Yeah, I am.
Excellent. Aiko, tell us a little bit about, you've got an illustrious background. What's your most recent work and interest?
Well, I think the one outstanding feature is that I sort of got lost in a number of different topics and managed to not know much about any of these now anymore, but interest keeps growing. I sort of did a grad school in clinical psychology originally, and got quite upset about the simplified approaches people take to trying to understand and model mental illness.
I see.
Patients with the same diagnosis differ from each other quite a bit, but they're usually subsumed into sort of categories and modeled as zeros and ones.
Yes.
And so I got upset and spent, after my clinical PhD, 4 years as a postdoc in quite formal sort of statistical groups. And, you know, some multivariate modeling there, some basic machine learning. Hence my question about feature selection, because in the social sciences, we have our own approaches, of course. And I wanted to sort of see how much what you do would align with this or not. And I think the most important, or at least for this group, interesting part of my work would be that we try to collect data of patients on their phone, let's say 5 or 10 times a day, where they sort of tell us what problems they currently have. So in the last 2 hours, you know, tell me the 10 most prominent problems you had, concentration problems, suicidal thoughts, eating problems for eating disorder patients, these sort of things. And we collect data for a couple of weeks or months, and then we try to build predictive models that work on a very small time scale. So you want to predict the next measurement point, and of course, ultimately also the distal outcome, if a patient transitions into depression or if a person gets healthy over time and so forth.
And do these phone-based methods solve the problem of very scarce data sets in psychology?
The problem with the phone-based method, so I also work with these very large epidemiological, more cross-sectional data sets, where we have hundreds and hundreds of variables, where feature selection is a problem. For the time series data we have, the issue is that you cannot query, you cannot ask a patient 100 questions 100 times a day. So you sort of need to do feature selection based on theory before you start collecting data.
I see.
And
so you have to kind of go into the field already with your features selected in a way.
Right. And then there's different ways you can personalize the feature selection. So in the Netherlands, quite a few clinics are now working with these methods where a clinician would interview the patient first, and then they would select features together that both think are important for that particular patient. But of course, then you cannot compare the model for patient A with patient B anymore, because you have fundamentally different features. And the compromise would be to select the same features for a group of patients so they remain comparable.
I see.
But,
yeah, I mean, I think the classical way of selecting features, and maybe I didn't answer your question well enough. I was answering it in the sense of deep learning, but usually there's some cost function involved, which you're trying to minimize. And then most textbooks talk about systematically removing individual features and then seeing what impact that has on reducing your cost function. I think it's okay for simpler models, simpler regression models, maybe even the tree-based ones and support vector machines and things like that. But specifically for deep learning, there's this caveat of interaction between the inputs.
I was thinking the same. So you could remove a variable that is highly collinear with others, and at the same time has no impact or no relation with the dependent outcome that you want to predict.
Yes.
But still, there might be a scenario where this variable is very important in deep learning due to some weird interaction process.
Yeah, it's almost like what's that thing when you talk about necessary? It's a necessary feature, but it's not necessarily the best feature. It just has to be there. No, it's fascinating. Thanks, Eiko. I think in this group, you're all welcome, of course, to contact and reach out to each other via email and to talk more about if something sounded interesting to you. Please reach out. And the last thing I want to say is please get in contact with me if you need some architecture, if you need some credits in Google Cloud. Just reach out to me, and we can maybe hook you up with some GPU time to process models and to do a bit of research. Let me know if that's something you want. Thank you very much, everyone. I really appreciate you joining this first edition of Machine Club. It's crazy how fast an hour goes when you talk about interesting things. I'd love to see you at the next one, and I'll keep you updated when that will be. Have a good Christmas, and we'll see each other again.
Thanks, Evan.
Thanks, Evan.
Thanks a lot,
Thank you.
Evan.
Thank
Thanks.
you. See
Bye.
you.
Thanks,
Have a good
Evan.
one. Cheers, everyone. Bye-bye.
Bye.